Hello everybody, good evening. Any doubt, any questions? Any doubt, any question? So planning to have a quiz. Okay, so we don't have much time, so this is two. And since we have finished chapter 6 as well, so we will also have chapter 6. So anyway, chapter 2, 3 are easy. Chapter 5 is also easy, not much there. So we will include chapter 6 as well. Okay, and your quiz will be on next week on Thursday. Okay, 10, then 11, 18. So on 18th, you will have the quiz. Okay. Okay, so time will be same 4 to 5. Okay, guys. Okay, so let's start the tutorial. So I will just write here the quiz number 2 will be held on Thursday. Thursday is 18th November. Okay, and 4 to 5 p.m. Okay, and syllabus is chapter 2, 3, 5, 6. Okay, so your homework is based on 2, 3, 5. So chapter 6 as well, because we have finished our chapter. Today we will have from chapter 6. Any confusion? Any question you have? Okay. If no question, then let's start the tutorial for chapter 6. And we have tutorial chapter 6 and tutorial problems. We have B6, and then we have 1, 5, 8, 12, 13, 16, 18, 21, 22, 23, 28. Okay, so varieties of problems. So this chapter is on the root locus actually. So it's important because it's a new concept. So let's start with the B61. Okay. So number 1, it says plot the root loci for. So B61. And what is given? Given is feed forward transfer function, which is GS equal to K, then S plus 1 divided by S square, and given HS equal to 1. Okay, and we have to draw the closed loop, the root locus for the closed loop control system with this. Okay, so how to do it? Okay, so basically here, as you see in the lecture notes, okay, we have to start like this, and I will use red color for it. Okay, so first look at, okay, let us use different color, maybe blue color. Okay, so let's see numerator, denominator. So we have to plot what is root locus? Root locus actually traces the roots for the closed loop system. Yeah, this is the S plane, and this is the feed forward system. The feed forward transfer function multiplied by HS is the, this multiplied by this one is the open loop transfer function. So GS is feed forward transfer function, GS times HS is the open loop transfer function. So HS equal to 1. So in this case, feed forward transfer function and the open loop transfer function both are exactly the same, right? Okay, now in root locus method is basically given the open loop transfer function, you can trace, you will know beforehand all the possible points where the roots of the closed loop system will be, so that you can decide accordingly, so that in the real you can choose one of those points. So there will be a plot which shows through which the roots are will be there depending on the value of k. You value the k, change the value of k, your points will also change, and all those points together is known as root locus. Okay. So how you plot it? So there are some rules, and that is discussed in the lecture notes. And you start with first with the poles, and poles are this. S square is equal to 0 in this case. Is the, you can find out the, these are the roots of that. So S square equal to 0. So there will be a double poles here. So we have two of them, right? So we have two of them here. Two of them. Yeah. So we can also write it like this. So this is, so this one is real. Yeah. So real S, this S plane. So this is real S, this imaginary S. Or you call it a sigma, you can call, and this is called J omega. Yeah. Okay. Okay. So we have two poles here, two of them, and then you look at here. So these are zeros, equals to zeros. So S plus 1 equal to 0 is the equation from where you can find a value of S. So S equal to minus 1. So minus S equal to minus 1. So the 0 is here to minus 1. So we have 0, we denote it as circle, a small circle. So we write minus 1 here, 0 here. So basically the roots of open loop transfer function, I mean the denominator polynomial is known as the poles. There are two poles here and then a 0 here. So how do you start? First you have to mark where those poles and zeros are. So poles are here, zeros are here. Then we draw the root locus on this, on the real axis. So this is the real axis of S plane. This is the imaginary axis. So on real axis, how do you do? So there are three. So you start from the right, and between two consecutive poles and zeros, you draw a line, right? So here you have two of them. So you have draw a line between them, means there will be a point only. So there's nothing but simply a point. So let me use a different color for the maybe I use red color here. So this will be just a point. Yeah, and then so there are two roots, or there are two poles. Both are connected. Both will be connected by the point only. So we draw a point here, and then after that, there will be no line between second and third. So between first one, two, between the first and second, there will be a line, and then there will be no line between second and third. So this is the first, second, third. So between second, third, there is no line, and from third onward, there will be another line which will go to the infinity, minus infinity. So you have a line like this. Okay. So root locus on the real axis, it will be like this. So here point and here point. But this is not sufficient. Not sufficient meaning that you know that when you vary k, then the root of the closed loop system will move from the pole and will go to move towards the zeros, right? So we have 0 here, and we have poles here. So there will be a connection between this and this somehow. But here it cannot go. We know that it cannot go here. Yeah. So what's the root? It has to fly, right? So it has to go something like this, or something like this, or like this, and go like this. So that we have to find out how it goes. But it will go for sure. Yeah. Okay. So how to find out? So first of all, we have to look for the asymptotes, number of asymptotes that it will have. Okay. So now number of asymptotes we are talking about. How do you find out? So look at this one. So number of asymptotes. Okay. So number of asymptotes. Number of asymptotes, as you know, in this case, what do we have? We have s plus 1 over s squared. So we have number of asymptotes will be simply is equal to, you have n minus m. N in this case is 2, m is minus 1, is equal to only 1. So where n is equal to number of poles and m is equal to number of zeros. So 2 minus 1 is equal to 1. Okay. Okay, so that means there is only one asymptote. That really means that there is only one thing that goes to infinity. And here we have that. So what you see here, this is the one which will go to infinity, okay, to minus infinity, right? So in fact, we can write that here. This goes towards minus infinity. So right like that. So this is the asymptotes that goes, and only one. Then you know that it will have 180 degree only, minus 180 degree. So this is how on the real axis only it will go. Okay, there is no other thing. Means there is no root locus which is moving this way or this way and that way. Okay, so only one which goes like this. So this is settled. Okay, now how do we know whether there is something like this? How do we know? So for that, we have to find out the break-in and breakaway points, right? So for that, what do we do? So what is known as break-in and breakaway points. Okay, and how do you do? So we have the open loop transfer function, which is given by like this open loop transfer function is equal to a k s plus 1 divided by s squared. So closed loop will be closed loop transfer function is equal to 1 over, so this will be equal to this, let us say you call it GS, right? Anyway, HS is equal to 1 in this case. So this will be simply GS divided by 1 plus GS. This part it will be. Okay. So what we see here in this case is our characteristic equation is basically this, right? So 1 plus G plus S is the characteristic equation, right? So basically characteristic equation is 1 plus GS, and 1 plus GS is 1 plus K and then you have s plus 1, s plus 1 over s square, right? This is equal to 0, or k equal to simply minus s square over s plus 1. Right? So this we have discussed already, so what we do in that case, breakaway, breaking points, we know that there's a discontinuity here, means this is not discontinuity but slope change. Yeah, so because of that, what happens, dk over ds has equal to 0. Yeah, so dk over ds becomes equal to 0 at that point where the breakaway points it discussed in the lecture notes. Okay, so we can calculate now. So this tells us dk over ds equal to minus 2s s plus 1 minus s square divided by s plus 1 square is equal to 0. This tells us 2s square plus 2s minus s square equal to 0, or s square plus 2s equal to 0. That tells us s plus 2 equal to 0, s equal to 0, and s equal to minus 2. So this tells us there are 2 points where there are there is a break-in and breakaway. Okay, so where s equal to 0 and s equal to minus 2. Yeah, so let's go back and let's see. So as per this, there are 2 points. So let's go to red. So it says that at s equal to 0, this is s equal to 0, and here will be s equal to minus 2 as well. So let's write it first. So this is, let us say minus 2 is here. Okay, so there is a break-in, breakaway points. Yeah, and that means the somewhere here, I mean, at s equal to 0 and s equal to minus 2 means it goes up and comes down somewhere like this. Yeah, whether it will be circular or not, if you plot it, all the points, you will know. Yeah, but you can check, you can do some checking whether it will be circular or not, or and how to do that. So right now we are just guessing that it will be circular, goes like this. Yeah, actually we have to trace all the points, so all the points we have to plot basically. So finally we have to for different s we have to like plot. Yeah, okay, now given we are just guessing here, but we can find more details. More details means first will be like, what is the angle of this, for example, what is the angle of this. Yeah, so here breakaway, what is the angle of that, and so on. And but you know that from the nature of the root locus, you know that it starts from a pole and this ends up at the zeros. So there are 2 zeros. One zero is at s equal to minus 1. The other is at infinity. Yes, at minus. So, so this will go like this. Yeah, it will go like this, and then from this point, this will, one branch will head to the right direction. The other will be to the left direction. Yeah. So what is the meaning of this is, when you change the value of k, is k equal to 0, the root of the closed loop system will be here. If you increase k, you start changing, you're going, there are 2 roots, it will go like this. Yeah, then at a particular value of k, it will be here. You increase more, you will have 1 here and 1 here. And k equal to infinity, one will be here, another will be at minus infinity. So this is what the interpretation. Other details you can work out. What is the angle? Okay, so this is is a breakaway, right? So what's the angle of breakaway at the breakaway points? So there is a condition that it has to and what is the condition? Condition is that total angle has to be equal to 180 degree or 2k times plus 1, or means odd, basically either 180 degree or 180 or 180 plus 360 degree, or plus n times 360 degree, 180 degree plus n times 360 degree, basically. So it has to be this is done because you have to make total angle, so is a multiple of 180, but not even multiple, has to be odd multiple. So why? This is because let us say at this point, at this point, if you want to see the angle of this, so let's okay, just like an example. Okay, you will follow this only if you have been watching the lecture videos. Otherwise, it may be difficult, you know. So there, it has a lot of things there. Okay, now say you have see here. So we have which point? We have -1 here, and then you have this. So let's see. We are talking about a point. This exaggerated, it is too much up there, exaggerated. But if you look at that, then see the at this point, so this point, so you have let's see what will be the angle. Okay, now this point is very close to this point. Okay, so that means almost this is 0 basically. Yeah, but what is the angle? What is the angle that these poles are making? So we will see that this will be making 90 degree, right? So pi over 2. So both of them, there are 2 points here, right? So both of them making pi over 2, right? Okay. So if you see the angle that they are making, that will be pi over 2. And what is the angle this is making? What is the angle this is making? So this point is very close to this point. Yeah, so that means the angle making is 0. Yeah, so this is basically is 0 angle. So total so this is like this. See, your angle will be like for GSHS angle, if you see, that is of angle of S plus 1 and S square will be angle of S plus 1 minus summation of 2 angle of S, right? Now this angle at this point, right, from here to here, this is making 0. See, this is making 0. This is making 0, and this is making 2 times pi over 2. So this minus pi equal to minus 180 degree. So condition it is fulfilling that angle should make with these the poles and zeros with algebraic summation has to be multiple, the odd multiples of 180, and it's here this condition is satisfied where we assume that this point goes up like this. That means this breakaway is with the 90 degree. So if breakaway is with the 90 degree, that means it's a circle, right? At least here it is a circle, right? So the is perpendicular to this. So and so on. Okay, you can similar test, but this is how you can guess basically that it is a circle. Yeah. For more, you have to investigate more basically, but this is how it is. Okay. Any question, guys? Okay, I explained from the basics, although it is given like in the lectures, but of course not completely, because otherwise it will repeat of lectures only. But you have to first watch the lecture videos, then only you will understand. Yeah, so remember. Any question, guys? Okay, if not, then next one. So next one is hold on, is 5, 8, 12. Okay, 5. Okay, so B65, and here plot the root loci for a closed loop closed system with GS equal to K S plus 0.2 divided by S square S plus 3.6. Okay. Okay, and here also HS is equal to 1. Okay, so here also we'll follow the same thing. So we start with our S-plane. Okay, and the first thing we have to do is put all the poles and zeros first. Yeah, so here are the poles. Poles are, look here, we have S 3.6. S square here. So of course we have 2 of them here. Yeah, and then we have at S equal to minus 3.6. So S equal to minus 3.6. So let's put it here and write it minus 3.6. Then we have 1 0 at 0.2. So let's here we call this one as minus 0.2. So we have that. Next step will be to complete the root locus on the real S plane, the real axis. This is the real axis. So there are 2 of them already here. So we will have just a point here, just one, and then we will have between these and these. So between these and these, then between these and these 2. So we go from here to here. Yeah, done. Now next is we have to see number of asymptotes. So number of asymptotes. So number of asymptotes is equal to, we have to see how many poles are there. So poles are 3. Poles are 3. And then we have S1 0. So we have a number of asymptotes will be equal to n minus m, and where n is equal to 3, m equal to 1 equal to 2. Yeah. So if there are 2 asymptotes, then what happens? Then they will be up and down only. Okay, it will be it will going up and down. Yeah. Okay. Why up and down? Because the asymptotes try to be further possible from each other. Yeah, so if there is only one, as we know that it will go to minus infinity. If there are 2, then they will go vertically like this, and we can see also how it will go. We can find out the angle. Okay, now we can find out the angle. So angle of asymptotes. Yeah, and those is equal to, we have 180. So we write 180 times 2k plus 1, right? Okay, and then we have, okay, just a minute. So then we have this s square plus s plus 3.6. Numerator is this one, denominator is this one. So we have all the angles we have to count for this one, right? So we have corresponding to this one, the value of, so okay. So okay, so okay, so what we are talking about in this case is like they are divided such that they are further from each other. Okay, so here we have n. How many n? 2 plus 1 is 3. And here we have m is equal to 1. So we have to divide this by n minus m. And here we have 180 divided by n minus m. So we have 3 minus 1 and 180 divided by 2, which is 90 degree. So 90 degree meaning that it is plus minus. Okay, remember that this is plus minus. Okay, so plus minus 90 degree. So that really means that asymptotes will go 90 degree, plus minus 90 degree. So one will go at plus 90 degree, the other will go at minus 90 degree. That's what it tells. Okay, now next is the value of the breakaway points. So just hold on. Okay, so breakaway points values, the root, the points, or rather these are the asymptotes or let's write it points where the asymptotes meet the real axis. Okay, and this is given by s equal to, we have all the poles, so we have minus here. Okay, then poles p1, p2, p3, then we have zeros, minus we have to write, so we have a z1, z2, z3, and so on, divided by n minus n. So in our case, we have poles, we have 0, 2, 0, and 1, 3.6, right? So we have 3.6 and 2 zeros, so we'll write that. So basically here s equal to minus 0 is 1, another one is 0, then we have minus 3.6, and then we have 0.2 probably. So okay, so we have 0.2. So minus 0.2 divided by n minus m is 2. So all the poles we write first, so 0, 0, then minus 3.6, those are the poles, minus we have zeros, so 0 is 0.2 divided by 2. So this gives us roughly where the asymptote will meet the real axis. So is equal to, we have minus 3.6 plus 0.2 divided by 2 is equal to, we have minus, so we have minus, and then we have 3.6 and plus 0.2, so minus 3.4 divided by 2 is equal to, and we get 1.7. Okay, just a minute, guys. Okay, fine. Okay, so basically this what is just tells that where these asymptotes will meet basically. Okay. Just a minute, just a minute. Okay. So, okay. So here, when we use this one, P1, P2, P3, Z1, Z2, Z3, these are basically not the roots, rather they are. So, okay, so here we have to be careful. So here it has to be plus, and here this also has to be plus. So we have plus here, and this one is minus, and hence we get minus this, then minus 1.7. Why? Because here these poles are not actually poles. These are basically like this. So remember, like it means that you are writing HS times GS as S plus Z1, S plus Z2, and so on to S plus Z, S plus GM. Here you are writing S plus P1, S plus P2 to S plus Pn. So actually, actual poles will be S equal to minus P1, minus P2, and so on. Yeah. So that really means that we here, when we are writing this general formula, then we have to be careful here. So we write here P1 will be actual the minus of the root, meaning that if root is S equal to minus P1, we take negative of that and then we put. So if root is minus 3.6, so that really means we have to write here 3.6. So that's why we have 3.6 here, minus here again in this case also 0.2. So hence it will be 3.6 minus 0.2 over 2, 3.4 over 2, and hence minus 1.7. Okay. So now it's correct. So basically we go back here. So at minus 1.7, or and where is that point? So that point is somewhere here, right in the middle, somewhere here. Okay. At this point, which is minus 1.7, okay, not exactly in the middle, because in the middle it will be, so 6 to 8, 1.9 will be in the middle. So it will little bit away from the middle point of this line, Okay, so at minus 1.7, asymptotes are going to meet. So let's draw line there like this. So, okay. And we know that the asymptotes angles will be 90 degree, and we calculated that because 180 degree divided by 2 means n minus m is 90 degrees. So this is the how the asymptotes these are asymptote lines basically. These are the asymptotes basically. Yeah. So now we have to find out how it goes. So we know that it has to start from here, and it has to go from here to here. One will go like this. The another will another is going to like so. So we have 3 poles. So it has to go move something like this one, and it move has to move towards the 0. So this is how it will move. Another is somehow from here it has to go, right? So either it will go like this one or go like, so that we have to see how exactly it will go. But 2 points will be going like this, yeah, like this. Okay, so now we have to find out the breakaway points, whether it will break away from here or break away from here. So that we have to find out. So most likely it is going to be like this. Okay, so from this will move from here to here and then also like this one. Okay, so let us see how to do. So next thing will be to find out the break-in points. So breakaway points. And we have 1 plus k times s plus 0.2 and then s square s plus 3.6, right? Okay, is equal to 0, and hence we have k is equal to minus s square s plus 3.6. Yeah, minus s square 3 and divided by s plus 0.2. Yeah, okay, and here dk over ds is equal to, we have to find out. So here first minus, and then we have s 2s s 3.6. okay, then we have s square, and we have to multiply it by s plus 0.2. Then we have minus, okay, and s square s plus 3.6, right, and divided by s plus 0.2 square. Yeah, that will be equal to 0. And what we see here is there is a common is, okay, so we have to expand it to find out, and that will give us the points. Okay, okay, now if we put the value equal to s, you will get equal to 0. So we can see that s is one of the points. Okay, so if you put s equal to 0, it will be 0 here. So is 0 here, so the whole thing is 0, then 0 here. So all things will be 0 multiplied by this 0 and 0 here also. So you see that s equal to 0 is one of the points. So that means our breakaway points are here. Yeah, so this is the point for sure. Yeah, and what we see here is we need to know, we need to get the real numbers, and s has to be a real number to actually get the, so we get s equal to 0, and what we see is this is a cubic function, this is also a cubic function. So finally we have s equal to 0 multiplied by a quadratic function, and the quadratic function, quadratic equation will have complex, most likely in this case we'll have a complex roots, and that means they are not real, and because of that they do not lie on the real axis, and hence the breakaway points will be just one, s equal to 0 only at that point only, and hence you can see that the root locus will be, in this case, will be something like this. It will be something like this. Okay, just nature basically. So it's from here it will move, go. Asymptotes means this will be asymptote to this, right? Only to this line. So this is how it will move. Go like that. Yeah. And from here to here will be one, and then from here to here, go like this. Okay. Any question, guys? Here. Okay. I'm telling the roughly, the roughly rough guess. Exact, you can use MATLAB to draw, or you have to do more analysis basically to find out. Any question? Okay. Okay, so let us see the next one. A 12, 13. Okay, 8. So B68, and it says that consider a unity feedback control system with the following feed forward transfer function. So GS is given to be K and S square 4S plus 8. So this is 8. Plot the root locus for the system if the value of gain K is set equal to 2. So later on, if K equal to 2, where are the closed loop poles located? So where are the poles? Where are the poles? Okay. So first you have to understand what it is asking, and then you will know. Okay. So first you have to draw the feed. So we have in this case, how will it look like? So let's draw the S plane, and then we have one root which is here at the 0. So one pole is here, and then there are two of them, S square 4S plus 8. So we have to find out. So we have S square plus 4S plus 8 equal to 0. And then what do we get? We get S plus 2S, S plus 2S square. So 4S plus 4 plus 4 is equal to 0. And hence we get two of them. We get S plus 2 is equal to plus minus 2i, right? Okay, and hence we get S equal to minus 2 plus minus 2i. So two complex we get in this case, as you see. Okay, and where are they? They will be here somewhere. So 0.2 minus 2. So we have here and here. Okay, such that the value, this is 2 minus 2, and this is also minus 2. Yeah. So we get the poles here, 3 poles. Okay. Now we have to draw, and how to draw in that case? So we start with the real axis. The real axis, there is none. Yeah. So we just there will be a line which will go like this. Okay, since real axis we have only one, so we have only one here which will go like this, and rest we have 2. Now we have to look for others. So now how many asymptotes? We will have 3 asymptotes. Why? Because there are n equal to 3 and m equal to 0. So we have 3 asymptotes. So what will be the angle? The angle will be plus minus 80 degree divided by, and then we have the divided by n minus m is the angle between them. So we have basically angle will be this. So 60 degree basically, right? Plus minus 60 degree. So we have so asymptotes will be going like this. Sorry. Asymptotes will be going like this. So we have 60 degree here, 60 degree here, and then total will be 120 degree. This will be 120 degree. This will be 120 degree, because all the asymptotes are such that they maintain the maximum angular distance. So if there are 3, there will be 3 angles, something like this one. And then you have to find out the break-in, breakaway points as we did that, and so on, right? Finally, when you got the root locus, as we discussed, also discussed in the video lectures, then the question here is, if k equal to 2, then what is the position of the root of the closed loop system? Yeah, so in that case, like we have to locate those values. Yeah, so for different k, the root we have to find out, right? So that means okay, so we can also write the equation. You can find out. So the closed loop system will have gs divided by 1 plus gs, because, right? So characteristic equation is equal to 1 plus k, right? And then we have these values s. Okay, just a minute. You have s square 4s plus 8. Okay, and this is characteristic equation. So just this is asking that if k equal 2, then what is the roots? Roots will be this s square plus 4s plus 8 plus k equal to 0, where k equal to 2. Okay? So basically root will be whatever the roots of this, 4s plus 8 plus 2 equal to 0. Okay? So whatever the value of then solve for s, and this is the this is what it is asking. Yeah, so this is asking set equal to where are the closed loop poles located. So you can solve for s, you can find out where the this is, and then you can show on this diagram where exactly it will be like this. So if you solve this one, you will find out that first you have to find out where the asymptotes will be there, and in this case the like asymptotes will be at somewhere like we have to first find out what where the asymptotes will be meeting. So let us say asymptotes is meeting somewhere here, and so the asymptotes will be something like this and like this. Yeah, and finally this will be something like this. It will go like this. Okay, just roughly I'm just guessing it will be like this. Okay, so this is because we have a pole here. So from pole it will go to 0, so it will go like this one. Here also we have pole, it has 0 is infinity, so and it has to go and be asymptote to this line, so it will go like this and this like this. Where these asymptotes will meet, again follow the rules. Okay, as we also did for the previous question, we can find out where the asymptotes is meeting the real axis. Yeah. Okay, so for k equal to 2, you can tell where those points are. You can go and you can solve those, and you can tell that points will be here and here and here. You can tell like that. Yeah, there will be 3 points because there will be 3 roots. So there will be if for open loop system, here we have 3. So for a closed loop also we will have 3. Okay. Any question, guys? Anything? Okay, this topic is something that you have to first go through the lecture video, otherwise you will not understand. Yeah, so in lecture videos, motivation is given, what actually it is, what is the meaning of that, why we do it, everything is there. Here we have done, assuming you have seen the videos. If not, then you have to watch it again. Okay, so see the lecture videos first and watch it again. Then you will understand. Okay. So anyway, for those who joined late, okay, so we will have quiz on Thursday, quiz number 2 on Thursday, 18th November. Okay. And it will have whatever covered so far. Meaning that chapter 2, 3, 5, and 6. All of them are there. Okay. Okay, any question? If not, see you next week then. Okay, thank you.